Hello everyone, this is Jason. In this video, we will talk about the feature definition in ZW3D 2x Cam, in which I will introduce the feature overview and feature type, feature creation methods, profile creation and introduction of related options, 2x common features, chamfer and fitted features, nesting profile, features corresponding to 2x operations, and cam sketch management. First of all, I will introduce the feature overview and feature type. The features in 2 or 3x cam are used to define the processing range of the plane and define the guideline for creating the two paths. These two images can help you better understand. The first one is to define the processing range of the plane, means that ZW3D will only generate a two path within the profile. The second one is using the profile as the guideline to generate a two path. When creating features, there will be three types: part, contained, and stock for you to choose. As shown below, part is used to define the processing range, which means the tool cannot pass, or used as the guideline for creating the two paths, applicable for 2 and 3x. Contained is used to limit the range of the tool movement, normally for 3x. We will also have more details in 3x Cam introduction. Stock is used to define the boundary that the tool can pass, often for 2x external engage. In addition to feature types, there will also be geometry types in Cam Manager. Now let's go to ZW3D and tell you the relevant usages. Okay, now let's take a look at the Cam Manager. Under the geometry, there is a part and a stock. Part here is the workpiece, and the stock is the raw material. And for the feature types, I will use spiral cut 1 to show you. Part is used to define the processing range that the tool cannot pass. Stock is used to define the boundary that the tool can pass, so the tool can engage from outside. In the last page, I've introduced feature overview and feature type. You may want to know how to create features for two-path calculation. So in this page, I will show you the methods to create features. 3 methods in total. Actually, in the images below, I have listed step by step. First one, click the corresponding feature under the Setup tab in Ribbon. Second one, in Cam Manager, right-click on the part, then Add Feature, then select the corresponding feature. And the third one, when you create a new operation, it will pop up Select Feature for Operation dialog box automatically. Then click Create button to select the corresponding feature. After that, you can go ahead to select the features from the model. Now let's explore more about the profile creation and related options. After you select the corresponding features according to the last chapter, you will see the profile dialog box. I have listed the commonly used options. Input type is used to define the type of object you can select on the model. Commonly used: curve, profile, surface, and feature. Quick chain pick can realize chain selection after ticking, which is the same effect of Shift plus left mouse button. Loop. This option will appear only when the input type is feature or surface. Is to select different loop type. If I select the surface, outer means that I will keep the outer profile of it. Inner is the opposite. After you confirm the selection, you can move to the Profile Feature dialog box. Is used to add, remove, and modify feature attributes. If you still remember the feature types in the first chapter, the option is right here. You can assign the class type to be part, contained, or stock, and all the selected profiles will be listed here. The Attributes tab is to define the relevant attributes of the feature, and the Profile Members is to modify the attributes of the features like offset, draft, and tool location is mainly used in 2.5x. I will have further explanation later. And add and remove profile, as its name suggests, is to add or remove features from the list. Now let me introduce a little bit more about the profile members. First is the tool location. It's used to define the location of the boundary between the tool and the profile. It has three types: tangent to boundary, on boundary, and pass boundary. For the closed or open profile, the tool path location is related to the direction of the profile and the option machining side of the profile cut operation. To better understand the meanings, please take a look at the images below. The blue circle is the tool. The following are different situations of the tool location. The second one is offset. Is used to define the offset distance between the tool and the profile feature boundary. Here I posed two images. Tool location is on boundary. Offset value is -8 and 8 mm. You can see the differences. And I will have details introduction in ZW3D later. There's still one more attribute, draft. I will introduce it in the chapter, Introduction of Operations. Okay, now we back to ZW3D. First is to introduce the methods to create features. You can go to Setup, then select the corresponding features. Or you can right-click on the part, then Add Feature, then select the corresponding features. I recommend you to use this method. The last one is to create a new operation. Then it will pop up the select feature for operation automatically. Then click Create, then select the corresponding feature. And in the Profile dialog box, there are some options for you to select the features from the model easily. Input type, we commonly use curve, profile, surface, and feature. Curve means that you can select the curve or the edges from the model. When it is profile, you can select the sketch from the ZW3D CAD or CAM environment by just one click. And if it is surface, means that you can select the surface from the model. When it is feature, means that you can select the features created in ZW3D CAD environment. Please note that it can only recognize the features created in ZW3D if a model was imported from outside. The feature cannot be recognized in ZW3D CAM. Now I switch back to curve. The quick chain pick. This option can realize chain selection. And when the input type is feature or surface, the loop option will appear. It can help you to select the inner or outer profile of the surface easily. For example, now I use outer and uncheck this one first. Then I select the surface and click OK. It will only keep the outer profile of the surface. Then I will also show you the effect of inner option and surface, and this time I use inner. Then I select this surface, click OK. Then it will only keep the inner profile of the surface. After you confirm the selection, you can click OK, then go to the Profile Feature dialog box. Class here is to define the type of the feature: part, contain, and stock. And here are the attributes and the profiles. All the selected profiles will be listed here. You can add or remove the profile from the list. For example, now I add a curve to the list. And of course, I can remove it from the list. Next, I will show you some cases to introduce the tool location and offset option. Let's take a look at these operations. I will introduce tool location first. The first situation is for closed profile. We double click to go into the profile feature dialog box to check the tool location. These three curves I set it to tangent to boundary. And this one is past boundary and this one is on boundary. Then we can double click to show the tool path and use verify to check the effect. Now it is tangent to boundary and this one is past boundary and this side is on boundary. You may want to know where to specify the inside or outside of the profile. It is right here, the machining side. You can specify the inside or outside of the profile. For the open profile, along the direction of the profile, it can specify the left side or the right side of the profile. So that's what I'm going to show you next. Please take a look at these three operations. Profile 3, 4, 5 are the same edge and the direction also the same. So this one, the tool location is tangent to boundary and the machining side is left. So the tool path will generate on the left side of the profile. We can use the verify to check the effect. Now it is tangent to the boundary and this one is on boundary and this one is past to boundary. You can also use the verify to check the effect on boundary and past boundary. Then is the offset option. So the first situation is for the closed profile. We double click to check the tool location and the offset value. For this curve, the tool location is past boundary and the offset value is 0 mm, and this curve is on boundary and offset value is 8 mm. Then we can double click to show the tool path. Because the machining side here is inside, so even though the tool location is on boundary here and it will offset to the inside by 8 mm, and if the tool location is past boundary, even though the offset value is 0 mm here, it will offset the tool radius from the profile by default. And the next is the situation for the open profile. First, we double click to check the tool location and the offset value. The tool location here is on boundary and offset value is 0 mm. Then the tool path will generate on the profile. Then I change the offset value to 8 mm because the machining side here is left. So even though the tool location is on boundary, it will generate the tool path to the left side of the profile by 8 mm. So that's the introduction of the offset option. Now let's go ahead to introduce the commonly used features in ZW3D 2X CAM. There's profile and pocket. Profile is that you can select the curves on the model to define the processing range of the tool in XY plane. While pocket is based on that with an additional attribute of processing depth. Please check the images below for details. Now we back to ZW3D and see the difference. First, I will create a profile and I use the curve and I select these curves and click OK. Then you see the attributes here and I click OK to keep the profile 3 and I will also create a pocket. Then I can switch the filter here, but I recommend use this surface or feature because it can recognize the depth automatically. And after that, I need to click the middle button of the mouse to confirm the selection. Then you see there is an extra attribute, depth. In order to see the difference, I will create a ramp operation and use these features to create the two paths. First, I will use this profile and OK, and select a tool, calculate the two paths. Then you see, and we can change the machining side to left and calculate again. Then you see if you only have one layer of the two paths, then I create another one and use the pocket as the feature, and I double click to hide this one first and calculate. I also need to change the machining side left. Then you see it will recognize the depth of the pocket and generate the two paths based on that. So that's the difference. In addition to the common features, in ZW3D 2X CAM, we will also have some exclusive features for special operations like chamfer, turnaround, and nesting profile. Now, let's go ahead to introduce the details of them. Chamfer is that you can select the curve, surface, and chamfer features on the model as features of the chamfer operation. And turnaround is almost the same. You can select curve, surface, and turnaround features on the model as the feature of the turnaround operation. The creation methods is shown as below. Okay, now let's take a look at this table to see the differences between chamfer and turnaround features created by selecting curves, surface, and feature. I will use the chamfer feature as an example. Curve means that you can define the curve and its draft angle property as a chamfer feature to guide the two-pass generation. Surface is to define the surface as a chamfer feature to guide the two-pass generation. And feature, it will guide two-pass generation by selecting chamfer features. Now I will create a chamfer operation to show you the difference. By the way, in addition to create operations in ribbon, you can also right-click on the operations and insert operation. In this page, you can choose the corresponding operation you want to create. Now I need to create a chamfer operation, and I create a chamfer feature. Then I select the curve. Then I select this curve, and I need to click the middle button of the mouse to confirm the selection, and then click OK. Choose a chamfer tool, then calculate the two paths. Then this is the two paths, and the second one I will create a chamfer feature by selecting the surface. Then I select this surface, and I also use the middle button of the mouse to confirm the selection, then OK, and select the tool, and I hide this one first and calculate the two paths. Then this is the calculation result. And the last one I create the chamfer feature by selecting the feature, and you see it will select these two features. That's because the chamfer feature was created by one operation in ZW3D CAD environment so they can be recognized as a whole chamfer. So I click and click the middle button of the mouse to confirm the selection. Okay, then I select a tour, then calculate, and it will generate a tool pass on both sides. Next is the nesting profile. It's based on sketches created in the CAD environment or sketches import from the external DWG files. You need to create a blank and component nesting profile separately. Please note that the file type should be standalone sketch, and the creation method is shown as below. Now we're back to ZW3D to see how to create the nesting profiles. First, I need to create a new file. The file type should be standalone sketch. Then I can go to the File tab to import the external DWG file. And of course, we can also draw the sketches in ZW3D. For example, now I draw a rectangle here. Then I need to exist and create a CAM plan. And right click on the Geometry tab to insert a component. Then you see the sketches has been imported to the CAM environment successfully. Then I will go to Setup and create a nesting profile. And I select this rectangle and class. I need to set it to blank. Okay. Then I need to create one more. Is this circle. Click the middle button of the mouse to confirm the selection. And the class should be component. The quantity, I say 10, the offset 5. Okay, then one more is the rectangle created in ZW3D. Then component 10, the offset is 5. Okay, then you see the nesting profile has been created successfully, and I will create a nesting profile. I select these 3 features and I select a tour, and I will use the default ones and calculate the tool path. Then you see this is the tool path of the nesting. Okay, we've finished all the introduction of features in ZW3D 2x CAM. Let's make a summary of the features corresponding to the 2x operations. The ones outside the brackets are recommended. You can choose the features accordingly. Here I won't introduce it one by one. Next is the last chapter of feature definition in 2x. Users can draw the customized profiles through sketch function. And through sketch management, you can insert, activate, blank, and delete sketches. The difference between CAD and CAM sketch is that sketches created in ZW3D CAD environment can be inherited to the CAM environment, while the sketches created in the CAM environment are only valid in the CAM environment. And the sketch management function in CAM environment does not work on the sketches inherited from the CAD environment. Okay, now we're back to ZW3D to show you the sketch management. Here I'm in ZW3D CAD environment. These 2 sketches were created in CAD environment. And I can go to the CAM plan by clicking this little icon. Then you see the sketches created in CAD environment were inherited to the CAM environment. And here are the functions for the sketch management. You can insert, activate, blank, or delete sketches. Please note that all these functions are only valid for the CAM sketches. For example, now I want to activate one sketch. I cannot select the sketches inherited from the CAD environment, but I can select the CAM sketches. Okay, that's all for the feature definition in ZW3D 2X CAM. See you guys next time.